Welcome back everyone, part 2 of section 8-4, transforming quadratic functions. In the last example of part 1, you learn how to compare the graphs of quadratic functions. In this example, you're going to learn how to compare quadratic functions based on their equations. We're not given any graph, guys. The opening direction of the quadratic function g of x is determined according to the value of a. Since a equals 2 and it's greater than 0, it means the opening direction of g of x is upward, and the opening direction of f of x is also upward because the value of a of this function equals 1. It's a positive number, so the opening direction of both of them is upward. The vertical translation of g of x. Guys, we determine the vertical translation of any function from the added or subtracted number to x squared term. G of x equation equals 2x squared minus 1, and since there is 1 subtracted from 2x squared, this is exactly a vertical translation 1 unit down, so g of x is translated 1 unit down. Another characteristic is the width of the function, the quadratic function. Guys, g of x is wider or narrower than f of x. How do we figure out that? By finding the coefficient of g of x, the absolute value of the coefficient of a squared in the first function. Absolute value of 2 equals 2, and the value of 1, the a squared coefficient is 1 in the second function, is equal to 1. Guys, I understand 2 is greater than 1, but that makes g of x narrower than f of x. Finally, guys, the equation of the line of symmetry of both functions. Guys, for both functions, for g of x, we get the equation of the line of symmetry by using the formula x equals negative b over 2a. Guys, please notice that b is the coefficient of x term, and we don't have any x term in g of x. It means b equals 0, and when you divide 0 by anything ever, it gives you 0. So if you evaluate 2a, it's going to be 2 times 2, it's 4. 0 over 4 equals 0. So the equation of the line of symmetry of g of x, x equals 0. Same with f of x. The equation of the line of symmetry is equal to, the x term is disappeared. It means b equals 0 over 2 times 1, simplifies 2, is equal to 0. So the line of symmetry of both functions x equals 0. They have the same line of symmetry, guys. Guys, the quadratic function h of t equals negative 16t squared plus c is used to describe the motion of a falling object. Consider this guy is dropping an object from a height c. This is what we call the initial height from the ground. And when you drop an object from a height c, there is a force of gravity that takes this object down, and because of that we have negative 16 in our equation. That explains the force of gravity. T is the time, and the h of t is the height of this object at any particular time. So guys, how do we use this beautiful quadratic formula in real life? This is exactly example number 3. Two identical soft balls are dropped. The first one dropped from a height of 400 feet. The second one is dropped from a height 324 feet. We need to write an equation to describe the motion of each soft ball. h1 of t for the first ball. Guys, you remember the formula of the falling object. h of t equals negative 16 t squared plus c. You have to memorize this formula. So for the first soft ball, the one that is dropped from 400 feet, it's gonna be negative 16t squared plus 400. And for the second one that is dropped from height 324, it's going to be the same equation, negative 16t squared plus 324. Now guys, at first we need to compare these two equations of these two quadratic functions. Guys, almost everything is the same except the vertical translation. So if you compare the width of both functions, they have the same width. Yes, exactly. How do we know that? We compare the width by comparing the absolute value of a, the coefficient of t squared in both equations are the same, so the width is the same. The equation of the line of symmetry is going to be the same. The opening direction, both of them opens downward because a is negative. So almost everything is the same except the vertex of each parabola. It's gonna be different, and the vertical translation. Guys, h1 of t, the first function, is translated or shifted. How many units? Is shifted up 400 units or 400 feet. And the second soft ball, h2 of t, the second parabola, is shifted up. Both shifted up. How many units? How do I know up or down? Guys, if this constant c is positive, it's up. If it's negative, it's gonna be down. Since it's positive in both equations, so it's vertical a translation up 324 units. The second part is quite interesting, guys. We need to find when each soft ball reach the ground. When, it means I ask you about the time for both soft ball. Let me divide this page into two parts. The first part for the first soft ball and the second part for the second soft ball, guys. Guys, when the soft ball reach the ground, it means the height h of t gonna be 0. At the ground level, the height equals 0. So 0 equals negative 16t squared plus 400. This is the equation of the first soft ball. And guys, to solve this equation, you need to plus 16t squared to both sides. In order to get rid of this term, you add its opposite. Now simplify the result. 0 plus 16t squared simplifies 16t squared, and in the opposite side we have 400. If you want to isolate the variable t, you divide by 16. If you divide by 16, guys, you will get t squared equals 25. But wait a second, guys, our concern is t, not t squared. So if you get the square root of 25, you will get t equals 5 seconds. So the soft ball dropped from 400 feet reaches the ground in 5 seconds. This is s seconds, 5 seconds. And we're gonna do the same for the second soft ball. The equation that describes the second soft ball is h2 of t equals negative 16t squared plus 324. But at the ground level, h of t gonna be 0. So 0 equals negative 16t squared plus 324. Guys, to isolate the variable t, we need to add the opposite, plus 16t squared to both sides. 16t squared. Now guys, we can simplify this equation. 0 plus 16t squared is going to be 16t squared. This term and this term cross out each other. The leftover is 324. Now guys, we need to isolate t squared, so let's divide by 16. If you divide by 16 and get the square root of the answer, because this answer is going to be t squared, if you get the square root of the answer, it's going to be 4.5 seconds. Yes, so the ball dropped from 324 feet reaches the ground in 4.5 seconds. Guys, it does make sense. The one that dropped from 400 took longer time than the one that dropped from 324 to reach the ground. Pretty nice problem. Study well and see you in the next video. Bye.